Alright guys, welcome back. In today's video we're going to look at some trigonometry multiple choice questions. What I've done, I've gone through as much multiple choice past papers as I could have find, and I tried my best to take all the trig questions, and to my surprise there weren't much. I had a lot of repetition. So let's begin. First question: in the right angle triangle above, which trigonometric ratio is equal to 15/20? So let's recap our trig ratio. So we know our regular formula, we know we have our so, ca, toi. Alright, so this means sine is equal to opposite over the hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over the adjacent. Now it says which one would match. So let us see tan x. So tan would be opposite. Alright, so that means that we will have to find here when it says 15/20. So let's look at the sides that we have. In terms of the angle y, we have opposite and we have the hypotenuse. Alright, so we have the opposite, which is 15 over the hypotenuse. So which one has the opposite and the hypotenuse? That would be sine. So therefore sine y would be equal to 15/20. So therefore sine y would match. Alright, question 2. In the triangle PQR not drawn to scale, PQ is 13 cm, RQ is 12 cm, PR is x, and the angle PRQ is 90 degrees. The value of x is, no, you could find x two ways. You could, because it's a right angle triangle. Oh no, it is a right angle triangle, so you can easily use your Pythagoras Theorem. So using Pythagoras Theorem, we know that we have short side square plus short side square is equal to hypotenuse square. Sorry, forgive me of that. The hypotenuse is 13. So we're going to have x squared plus 12 squared is equal to 13 squared. So hence, we're going to have x squared is equal to 13 squared minus 12 squared, which gives us, so therefore x is equal to the square root of 13 squared minus 12 squared. And we know that 13 squared is 169 minus 144, which is 12 squared. So x is equal to the square root of 25, and the square root of 25 is 5. And for some, in one of my trigonometry videos, I had shown some popular trig ratios, and this is a popular trig ratio, 5, 12, 13. So therefore our answer would be B. Question 3. In the triangle ABC above not drawn to scale, the angle ABC is 60 degrees. AB is equal to 40 meters. The length of BC in terms of meters is, alright, so let us identify the sides that we have. So we want, and what we want to find. We want to find BC. So BC is right here. This is our BC. So what sides are we working? We're working with our hypotenuse, and we're working with our adjacent side. Now what trig ratio uses both the adjacent and the hypotenuse? Now we know that that would be cosine. So cosine, the angle is equal to the adjacent over the hypotenuse. Alright? Hence, we can automatically eliminate these tan And well, it would be easy to eliminate now without even working it out, because it would be cos 60 and not cos 30. But let's work it out. Cos would be equal to the adjacent, so the adjacent side, so cos 60 would be equal to the adjacent, which is BC, over the hypotenuse, which is 40. So to find BC, we're going to multiply both sides by 40. So then we get 40 cos 60 degrees will give us our BC. So therefore, our answer is going to be B. Question 4. So look at the diagram. A girl of height 1.4 meter stands 15 meters from the foot of a building, and the angle of elevation from the top of the building is 50 degrees. The height of the building in meters is, and then, alright, so let's look at it. So we have the girl. So therefore, think about it as we have a rectangle here. What do we know about rectangles? Opposite sides are equal. So if here is 15, then here would also be 15 meters. If her height here is 1.4, sorry, I'm just use a one stroke. So if here is 15, here is also 15 meter. If her height 1.4, that means here would also be 1.4 meters. Alright, so let us look at what we want. It asks us to find the height of the building. So let's call this first part here, so x or x1. Let's call it x1. We want to find here first, because we already know that from the rest is 1.4. So let's find it. So we have the opposite over the adjacent. So that's tan. So tan 50 is equal to opposite, which is our x1, let's call it x1, over the adjacent, which is 15 meters. So we know that in order to find x1, we're going to multiply both sides by 15. So we're going to have 15 tan 50 degrees equal to x1. So therefore, the height of the building is going to be whatever the value that we would have gotten for here plus the 1.4. It's going to be, so it's going to be 1.4 plus 15 tan 50 equals to the height of the building. Alright, so which one match? Our match goes with A. So 1.4 plus 15 tan 50. Alright, number 5. Very similar question. So your turn now. You go ahead and try number 5 ahead of me. Alright? Finish? Let me know when you're through. Okay? Okay. Alright, so a boy stands 15 meters from the foot of the building and observes the angle of, or the, you know, I don't read so well. You know, I use the book I read in school anyway. And observes the angle of elevation of the top of a building. So that angle of elevation is 40 degrees. Alright, let's apply what we know about rectangles. So we know that if here is opposite sides are equal, so if here is 1.6, then here is also 1.6. So this distance here is 1.6. And we know if here is 12 meters, then here is also 12 meters. Most of the real world application questions that they will give, even on the paper too, most real world applications that I've seen so far, most of them involve tangent, and that's because, you know, we kind of position ourselves down in the earth, you know. Anyway, moving on. So then let's find the height of the building approximately. Alright, so that means that we want to find, let's call here x1. Let's call it x1. So we have the opposite and we have the adjacent. So that's also tan again. So tan, and our angle is 40 degrees. And the opposite would be x1 that we want to find. And then over the adjacent, which would be 12. Alright, 12 meters. So therefore, to find x1, we're going to multiply both sides by 12. So therefore, we have 12 tan 40 degrees is equal to x1. So therefore, this is the length of x1. So therefore, the approximate height of the building. So the approximate height of the building is going to be the 1.6 plus, and that's 1.6 meters, plus the 12 tan 40. Alright, so which one match? So the 1.6 plus 12 tan 40, so our answer would be D. Alright, let's look at question 6. The diagram above, not drawn to scale, shows the angle of depression of a point P from Q is 35 degrees. If P is 25 meters from R, the height of QR in meters is. So I want to find the height here. Alright. But we don't have an idea of, so what we know is that we know that the angle of elevation, if this line is parallel and this line is parallel to each other, here would be your transversal line right here. So we know that the angle of elevation is equal to the angle of depression, and henceforth the angle of depression is equal to the angle of elevation. So if here, another term we call them their alternate angle segments. Alright, they're alternate angles. They're what we layman term they form Z angle. When you have when you have like two parallel lines, then you have this angle form the Z equal to this angle here. So we call that the alternate segments. Alright, so they're alternate angles. Hence, angle of elevation is equal to angle of depression. So therefore here would also be 35 degrees. Now we can go ahead and find our QR, because we have the opposite and the adjacent. So once you have opposite and adjacent side, you know that's going to be tan. So tan 35 degrees is equal to the opposite, which is QR, over the adjacent, which is 25 meters. So hence, to find QR, we're going to multiply both sides by 25 meters. So hence, our final answer, QR, is going to be equal to 25 tan 35. And that will match C. Alright. Question 7. You go ahead and try now. Very similar, very close to question 6. Alright. Let's look at it. See your diagram. See your right angle. So in the diagram above, not drawn to scale, shows that the angle of depression from a point X from Z is 30 degrees. If X is 10 meters from Y, the height of YZ, which is here, in meters is, so the same concept, angle of depression is equal to angle of elevation. That means so here will give me my 30 degrees. Hence I'll have the opposite side over the adjacent, and that's also tan again. So tan 30 is equal to the opposite, which is YZ, which is what we want to find, over the adjacent, which is 10. So in order to find YZ, we're going to multiply both sides by 10. So therefore we have 10 tan 30 degrees is equal to YZ. So therefore our answer is going to be B. Alright, question 8, item, and I deleted it because I'm taking it from multiple past papers, refers to the right angle triangle below. In the right angle triangle above, tan, so tan is what? The opposite side over the adjacent side. So what's the opposite side from the angle? Opposite side is 5, and the adjacent side would be where I always tell my students this. Any line you see the right angle and the given angle sit down on, that's going to be our adjacent side. So therefore the adjacent side is 12. So that's tan the angle is equal to 5 over 12. And that would match with B. Alright. Number 9. A ship sails on a bearing of 135 degrees. In which direction is it traveling? Now, whether you're a geo student or not, even in your maths class, your maths teacher will show you the cardinals. So we have our north, south, and I always say we. So we know west and the east. We know that north is 0, 0, 0, and 360 degrees, because you know you start and come right around. We know our east is 0, 9, 0. We know south is 180 degrees. We know our west 270 degrees. Now we can part this again, and then this gives us our northeast, and our northeast would be like a 45-degree angle, so we call that 0, 4, 5, 0, because it's bearings are written in three figures. Then we know that that's our northeast, and here would be our southwest, and southwest is 225 degrees. Cut this again. It's kind of chaka still, but that's alright. Here would be our southeast, and our southeast would be 135 degrees, which is the one we have interest in. Then here would be our northwest, which is 315 degrees. So therefore, a bearing of 135 degrees is southeast. So our answer is C. Alright, so our boat is traveling a bearing of 315 degrees. In which direction is it traveling? So we can go back and look at so 315 would be northwest. So therefore northwest, our answer for number 10 would be northwest. Alright. Alright, question 11. In the right angled triangle above, tan theta is, alright, so we know tan is the opposite over the adjacent side. So here is our opposite side, and here is our adjacent side. And we say tan, that's one more time, tan, the angle is opposite over the adjacent. So therefore tan angle is equal to 24 centimeters over 7 centimeters. So that's A, 24 over 7. Alright, number 11. Alright, so if sine the angle is equal to x, and x is a value between, alright, so x is less than 0 and x is less than 90, then cos the angle would be, alright, so let's draw a triangle. Let's draw a triangle. Let's call here theta. So we know that sine would be opposite. Here would be right angle. So opposite over the hypotenuse. Alright? So therefore, opposite side would have been x, because it says sine theta is x. So opposite over the hypotenuse would have been 1. So that's how they could get sine theta opposite, which will be x over 1. So sine theta is equal to x. Now they wanted to find cos theta. So cos would be the adjacent now, which we don't know. So the adjacent over the hypotenuse. So we know we need to find the third side of the triangle. Now what we can do, we go ahead and apply Pythagoras Theorem. Now let's just give a symbol for the adjacent. Let's just call the adjacent A. So in order to find the adjacent, we can say short side square plus short side square equal to the hypotenuse square. So then we have a square plus x square is equal to 1 square. So now we can say a square is equal to 1 square minus x square, because we would have subtracted x square from both sides. So we can comfortably say that a would be equal to the square root of 1 square minus x square. Sorry, I was writing plus. Alright, so minus x squared. We know that 1 squared is the same thing as 1. So a, which will be the adjacent side, will be equal to 1 minus x squared. So this side right here is now the square root of 1 minus x squared. Now we want to find cos theta, which is equal to the adjacent over the hypotenuse. So therefore cos theta, what's our adjacent side? The square root of 1 minus x squared over the hypotenuse, which is a value of 1. So hence, same thing as saying cos theta is equal to the square root of 1 minus x squared. So therefore that's going to be our A. Alright, let's look at number 13. Now number 13 depends. If you're an advanced student, it might come automatic to you. So we know we have our quadrant. So we know this little mnemonic that we use. So we say all students take chemistry. So so we have sine, cosine, tangent, and we have other one, cotangent and all these things. All these values are positive in this, so all them positive. In this quadrant, only sine is positive. In this quadrant, only tan is positive. And in this quadrant, only cosine is positive. That's why we say all meaning sine, cosine, tangent. Students, the sign is positive. So therefore it asks when theta lies in the following quadrant. So therefore theta, we would have found tan inverse, tan the angle is equal to negative 3 over 4. Therefore theta would have been equal to tan inverse negative 3 over 4. So if the angle is negative, so therefore tan is going to be, or angle is going to be negative. Cool? So hence, because it's going to be negative, in what quadrants will tan be negative? Tan is positive in quadrants 1 and quadrants 3. Therefore it's going to be negative in quadrants 2 and quadrants 4. So therefore the angle lies in the following quadrant. It's going to be in the second quadrant and the fourth quadrant. Just in case you might not know, this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Alright? So remember this little mnemonic. So all students take chemistry. So all of the values, sine the angle, cosine the angle, tan the angle are positive here. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. So that means if the angle is going to be negative, tan inverse of the angle is going to be a negative angle. Hence, tan is only negative in quadrants 2 and quadrants 4. Alright, so that's it. So our answer is going to be B. Question 14. The area of triangle ABC above. Now, once it's not a right angle triangle, and even a right angle triangle, you can still use half AB sine C. So the area is going to be equal to half AB sine C. Now, note briefly that this AB would be the two legs that surround the angle. So if I had 6 centimeters here and I didn't know what here would be, I would have to go ahead and find it in order to use that. So you can only use it when you have the two legs surrounding the angle. Alright? So let's look at the solution now. So A is equal to half. A is 5 times 5 sine 40 degrees. So 5 times 5, that's going to give us 25. That's 25 over 2 sine 40. Alright, so 25 over 2 sine 40, and that matches with A. Alright, let's look at number 15. Number 15, we have the triangle ABC above is a right angle triangle at C, and the angle ABC, we know that the one in the middle is the angle. So here when we say B, we say 40, AC is 20, the length of BC is, so BC right here would be our adjacent side, because we have the opposite and the adjacent side. So hence, that was going to give us tan. So tan 40, opposite, which is 20, over the adjacent, which is BC. So therefore, how we go ahead and find our BC. You can say BC, multiply both sides by BC. So now we have BC tan 40 is equal to 20. So to find BC, we're going to divide both sides by tan 40. And I work everything here the longer way, just for learning purposes. Alright, so tan 40 divided by tan 40, so we're left with BC is equal to 20 over tan 40 degrees. So hence our answer is going to be A. Alright, question 16. The triangle above, tan theta. So we have tan is the opposite over the adjacent. Always label your sides. So opposite, so tan theta opposite 5 over 12, and that would match B. Alright. Question 17. Alright, so we have a plane is traveling in a direction of 0, 4, 5 degrees and changes course in a clockwise direction to 135 degrees. The angle through which the plane turns is, but if you can draw a diagram, always draw a diagram. So the plane is here. Anyway, starting from that's where your north line is. 45 degree angle, here will be 90, so that means that here would be 45 degrees, so that would be your 0, 4, 5. We know we write buried in 3 figures. And then now, it change course, so then leaving again, put our next north line to 135 degrees angle, so we know, so here, so is 1350. So basically, so the angle through which the plane turns. So it want to find this angle right here. So therefore, it can be done many ways if you're extra. Some people, they can easily subtract. You can find angles in a circle. Whole heap of ways. Alright, so you have here is 45. So that means here so would be 135, because these two angles would add to give 180. If you're 135, 135, you could say 360 minus, so you get a 90 degrees. Or you could say 135 minus 45 degrees, and that would give you 90 degrees. Or you could add a 360 minus 135 plus 135, and that also should give you 90 degrees. So whenever you can draw your diagrams, it helps. Otherwise, some students just love them quick subtract and move on with their life. Alright, so that's it for question 17. See this question already? Alright, so that's going to be tan the angle opposite over the adjacent. So we see this already. So we get our 5 over 12b. Question 19. We have seen this already, but the answers shuffled are in the same position. So we have triangle ABC above in right angle at C. ABC equals 40 and AC equals 20. Find the length of BC. So BC is going to be, this is our adjacent side, so it's the opposite. Wow, we are tanned out today. So tan 40 is equal to the opposite, which is 20 centimeter, over the adjacent, which is our BC. So therefore, to find BC, you're going to have 20 over tan 40. Alright, so our answer is going to be D. I think our answer was D in the next one, but the same question, just that they shuffle up the answer location. Alright, question 20. Alright, so it refers to the following diagram. In the right angle triangle above, not drawn to scale, is 90, PQ is 50, PR 130, and RQ is equal to X. Tan R, tan PRQ, that means the angle would be here, PRQ, so this is the angle. So tan, let's call it R, is equal to opposite, which is going to be 50 over the adjacent side, which is our X. This is our up, and this is our adjacent side. Alright. So that's it, 50 over X, so therefore A would be our answer. Alright, let's look at number 21. Now, number 21 refers to the diagram below. Find the value of tan 180 minus X. Now, angles on a straight line add to give 180. So if here is 90, we wanted to find the angle here, we would have said what, 180 degrees minus whatever number this is. Would have minus X. So therefore this angle, so all of this angle here, so would be our angle 180 minus X. So therefore tan again, wow, I am very tanned out. So we have the opposite side, and then we have our adjacent side, which is C. So therefore tan 180 degrees minus X degrees is equal to the opposite B over the adjacent C. So therefore it will give us B over C, which is B. Alright, next one, number 22. From the diagram above, sine. So finally this is something here. So sine beta is equal to, sine is what? The opposite over the hypotenuse. So that is our sine. Alright, so we don't know what AB is, but AB falls in the typical ratio 3 to 4 to 5. So I can deduce that because it falls in ratio, we have the 5 and the 4, so okay, this must be 3. Or we can do our Pythagoras theorem quick. So we don't have, want to find AB, so let's say AB square plus 4 square is equal to 5 square. So AB square is going to be equal to 5 square minus 4 square. And then AB is going to be equal to the square root of 25 minus 16. And 25 minus 16 is what? Anybody can tell me quick? 25, no, this looks real bad. 25 minus 16, 9. Gee, it's the embarrassment for me. Anyway, AB, the square root of 9 is 3. So hence we work it out. So we can see that that is also 3. So therefore sine will be the opposite, which is 3 over the hypotenuse of 5. So therefore answer would be A, 3 over 5. Alright. Question 23. A plane is heading in a direction of 0, 4, 5. We did this already. And change its course in a clockwise rotation to 135 degrees. The angle through which the plane turns is, say, 135 degrees minus 0.45 degrees, and that gives us 90 degrees. For the full diagram and explanation, go back to question 17. Yeah, go back to question 17. Alright, let's move ahead. Next. Question 24. A ship sailed 8 kilometers due east. So ship is here, and where we are, that's where we put our north line. And we know that due east, so that's straight 90 degrees. 8 kilometers due east from A. So we're starting at A to B. So here would be our B. Alright. It then sailed 6 kilometers due north to C. So we have a north line here again, and then to C. So here will be our C. And it will be 6 kilometers. So therefore, which one best represents, which diagram below best represents the path the ship takes? Alright, so therefore, this one, because it looks automatically like the diagram that we have, it's funny, but the trick is it said that it went 8 kilometers due east, and this says 6. So, and then it went 6 kilometers due north, so it wouldn't be that. This went north before it got, and then this says now A, and then this go, but then this goes south. So then hence again, I'll put a north line here, because we start here, so too. We got 8 kilometers then, so our answer is going to be D. We're going 8 kilometers due east from A to B, and then so then put the north line here, so again good, because you're moving from B now to C, 6 kilometers. Alright, so our answer is going to be B. And our final question. Alright, so we have, no, not our final question, we have the length in AC of AB. So we see obvious Pythagoras theorem here. So we have the short side, one of our short sides, and we have our hypotenuse, and then we want to find the length of AB. So we know that's going to be AB square plus A square, because that side is A, plus is equal to the hypotenuse, which is the square root of A square plus 16 all square. Because that's like a saying, yo. AB square plus AC square is equal to BC square. Alright? I'm just not writing out all of that. So then we have, clearly we know that square root and square power to the half times 2, so we can now by the square root simplify square, so to the power of 1. So that gives us AB square plus A square is equal to A square plus 16. Now we can go ahead and say AB square. I will subtract A square from both sides. So we're left with only 16. So then AB is equal to the square root of 16. So AB is equal to 4. Remember, we subtract, let me just put it here, subtract A square from both sides. This is like solving equation concept, alright? And then, so AB is equal to 4. So the length of AB is going to be 4. So our answer is A. Next question. A ladder 5 meters long is leaning against a vertical wall. The foot of the ladder is 3 meters away from the wall. How far up the wall does the ladder reach? So let's draw a wall. This is my wall. Wall. Just stay to one man. Draw the wall properly. This is my wall. Wall. And then the ladder leaning on the wall. And the ladder is what? 5 meters long. And the foot of the ladder is 3 meters away from the wall. So 3 meters away. And we know that anywhere the wall and the earth meet at a 90-degree angle. Alright. So how far up the wall does the ladder reach? So it's asking to find this side, Pythagoras Theorem. Still the same ratio, 3 to 4 to 5. So here, if we have the 3 and we have the 5, then here is going to be 4. You can go ahead and work out your Pythagoras Theorem to show. Alright, I will just work it out if you feel extra. So we'll have x squared plus 3 squared is equal to 5 squared. So x squared is equal to 5 squared minus 3 squared. So x squared is equal to 5 squared, so 25 minus 9. And then we have x squared is equal to 25 minus 9 can give us 16. And then x is equal to the square root of 16. X is equal to 4. So you could do the long thing, but use the correlation. Know this one by the end of the video. You must know this one. 3 to 4 to 5. Alright. Next. And we're through. Alright. Thank you for watching. Leave me a comment. Check if all my answers them correct. And see you in our next video where I will look at working January 2005.